Okay, once again, our objective for today, I can solve and graph one variable inequalities. We're still on the same concept, is that correct? One variable inequality? All right. Now, I gave you yesterday a definition. We don't need the Frayer model for these notes. We already have this. And we're going to be on one variable inequalities for the next 4 or 5 days. So we know that they are expressions that are not equal to one another. I gave you guys examples, non-examples, and we know that the critical attributes is the fact that they have inequality symbols, one unknown variable, and we're not looking at quadratics. That means we only need exponents of no greater than 1 on the variable. Steps, we know the steps already, right? Simplify, isolate, plot, and check. Same steps. So what I need you to do, bless you, on the left-hand side of your Cornell notes on the Q column, I just want you to write simplify, isolate, plot, and check. So you can have those handy, please. Simplify, isolate, plot, and check. All right, from the top, I need you to skip from the very top. I want you to skip 3 lines. 3 lines. And before, we're not going to write this down. I'm just going to explain something that we already saw in equation. Everybody look up to the screen, please. Pens down, eyes up here. Focus, please. Here it goes. When we got to equations, we said that we're going to be looking at properties. Whatever we did to one side, we did to the other. So when we add something to both sides of an equation, it was addition property of equality. When we subtract something from each side, it's subtraction property of equality. Remember that? But now since we are in inequalities, now whenever we add something to each side, it's called addition property of inequality. If we subtract something from each side, it's called subtraction property of inequalities. Pretty simple? It's the same thing. Now we're just doing it with inequalities. Okay? So now, we already have been using solution sets. And here they introduce it and they call it set builder notation. And I'm just going to continue calling it solution set. So at the top of your paper, I ask you to skip 3 lines, right? And towards the middle, instead of starting on the left side, go towards the middle. And I want you to write this set, please. Like I said, skip 3 lines and then towards the middle. And then right there, you're going to write set x colon x less than 6 and close your bracket. So this is read in a certain way, so I need you to pay attention. Here it goes. Everybody look up. This is read like this. The brackets are known as, when you say the set. So this is the set of all x such that x is less than 6. Some of you are looking at me like, what? Yes, so check this out. The very first line that you skipped with your pen, I want you to write this down, please. On the very first line, write the set of all numbers x such that x is less than 6. All right, so here we go. I want you to point arrows. First arrow. You see where it says the set on the very beginning of the sentence? With a black arrow, you're going to point that arrow towards the bracket, because that tells us that this is the set. Next part, all numbers x in red, you're going to point a red arrow to the first x right here and overlay the x with red. Such that you're going to point a blue arrow from such that to the colon and overlay the colon in blue. And then the last part, x is less than 6, point a green arrow to the last part of the solution set, x less than 6, and overlay it with green. And that's how we're going to be writing our solution set from this point forward. That's why I wanted, notice that I introduced it in equations. Yesterday we did some of it, and from this point forward we're going to be using it more. Okay? All right, here we go. So this is red. Once again, it's red. The set of all x, or all numbers x, such that x is less than 6. Okay? So with that said, right underneath that, underneath your little solution set, I want you to sketch a line straight down, like so. And on the left side, you're going to write equations, and on the right side, you're going to write inequalities, all the way down. We're only going to do one of these exercises, and you're going to see how it's so easy because we already know what to do, because we already did it with equations. On the left side where it says equations, I want you to write x plus 5 equals 12. On the right-hand side, I want you to write x plus 5 is greater than or equal to 12. All right, here we go. Let's solve the equations first. So just to refresh in our memory as to what are the steps. Step 1, simplify. Can we simplify anything on this side? No. How about this side? No. So we're already done with step 1. Step 2, isolate the variable. We need to leave the variable by itself using the inverse operation. So what do we do here? Subtract 5. I'm going to do that in red. I'm going to subtract 5 from each side. So this is minus 5, minus 5. And we're left with x equals 7. So let's see. Did we simplify? It was already simplified. Did we isolate? Yes. What is the third step? Plot. So therefore, get a number line going right underneath that, like so. Here's 0. We got 1, 2, 3, 4, 5, 6, 7. And you plot your point. There it is. And notice that when we did equations that I asked you to start plotting some of your answers, remember that? And you're like, oh, Mr. Q, do we have to do that? I'm all, yes, at least for the beginning, so that you can get used to it, because guess what? Now we're going to be doing it for inequality. Okay, so simplify, isolate, plot. What is my last step? Check. So I'm going to rewrite the equation, and I'm going to open parentheses, plus 5 equals 12. And instead of the variable x, what number goes there? 7. So what is 7 plus 5? 12 is 12 equals to 12. Yes, that's true. So therefore my solution is x equals 7. So the reason I wanted to go over the equations part, because guess what? The same process is going to apply for inequalities. So I'm going to do that in blue. Let's do it together. To solve this inequality, I need to simplify each side. I can't simplify anymore. Step 2, isolate. What do I need to do here? Subtract 5 from each side. Cancels. We're left with x is greater than or equal to 7. Step 3, plot. So let's plot our answer. We got 0, 1, 2, 3, 4, 5, 6, 7. Here it is. Before I plot my answer, I need to check with the inequality symbol. Does it have a little equal sign underneath? Yeah, so that means I do plot my point. There it is. And let's read it. X is greater than 7. What numbers are greater than 7?
8.
8. How about 7.1? How about 7.000009? Yes, about 23. Okay, yes, so therefore any number this way, so that's why we shade everything on this side, and when you point an arrow. Not done, hold on. So simplify, isolate, plot. What is my next step? Check. So I'm going to rewrite the inequality, parentheses, plus 5 greater than or equal to 12. And instead of the parentheses, we're going to write what number goes in there? 7. So what is 7 plus 5? That's 12. It's 12 greater than or equal to 12. Yes, so that's so far so good. But check this out. For inequalities, I don't want you to only test one, which is that one. I want you to choose another number from the solution set that you highlighted over here. What number would you choose from over here? Very good. 23. Very good. So then you're going to open up another parenthesis, plus 5 greater than or equal to 12. And now I'm going to substitute in there my number that I chose from this solution set, and I said it was 23. What is 23 plus 5?
27.
28. Is 28 greater than or equal to 12? Yes. Well, guess what? Your attention, I'm not done. All this is a solution. Any number that I pick. So therefore, this is true and this is true. So my solution says that it's x greater than or equal to 7. So let's write our solution set in a bracket. The set of all x such that what? Such that x is greater than or equal to 7. Everybody with me? Okay, so pretty much that's it. Our homework for tonight. What pages are there? 125? Oh, 145, I'm sorry. 145 to 146. You're welcome. Number 1 through 33. Turn in your homework on your way out. Have a good one, guys. Enjoy your homework. See you guys tomorrow.